Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy. So far we have learnt about different aspects of phasis analysis, cyclicity and sea level fluctuations. So today with that background I would like to introduce two new concepts which are very fundamental in terms of sequence stratigraphy and interpretation of sedimentary environments. So these two terms are the concept of base level and accommodation. So this we will discuss in this class and also in the next class. So this concept of base level and accommodation, these are very important term, very fundamental term, and the entire process of sedimentation, erosion, accumulation of sediments, these are controlled by these two primary factors, or these are rather defined in terms of these two primary factors. So base level is commonly defined as the highest level to which a sedimentary succession can be built. There is a definition which was given by Tournefille long back in 1939, and after that there are several modifications of this definition as people started working in the field of sequence stratigraphy, in the field of cyclicities of sedimentary successions. Several definitions of base level were proposed, and there were a lot of debates as well regarding this definition of base level. Finally, in 1991, Cross proposed a very simplified definition of base level, which says that base level is a surface of equilibrium between erosion and deposition. That means it is a surface, definitely kind of conceptual surface, above which there will be erosion, below which there will be deposition. So it is the surface of equilibrium between erosion and deposition. This definition is a very simplified one, and it almost explains all sedimentary processes associated with base level. It properly defines the concept of base level. So in general, particularly when we talk about the marine basins, marine conditions, base level is more or less considered as equivalent to the sea level. However, later on we will see that the sea level may not be exactly the same as the base level, or in a reverse word, base level is not always synonymous to sea level. I will explain this later on, because normally whenever we define base level, it is associated with or defined in terms of different processes which controls sedimentation and erosion in that particular marine basin. So the erosion, how much erosion will go on, it depends on not on the water depth, but many times on the energy condition, particularly in terms of the wave and current conditions, their energy conditions in that marine basin. So depending on that, and in relation to the amount of sediment supplied into that particular basin, the position of the base level is determined, which may not exactly coincide with the position of the sea level at that particular time. So the extension of this base level can be done into the continents, and definitely continents normally they lie above the sea level. So if we try to extend this particular surface towards the continent, it will continue into the subsurface. So always the continents will try to come down to that particular level through continental denudation process, continental erosional process. So always in the continental side, surface processes, they will have a tendency to reach to that particular level of denudation, which is equivalent to the base level in the marine basin. So on the continental side, the processes of aggradation versus incision are regulated through a particular surface which can be considered as almost equivalent to the base level in the marine system. So the name of that particular surface in the continental part is called as graded fluvial profile or equilibrium fluvial profile, and it is associated with the fluvial system because this kind of adjustment with respect to the base level can be expected in the fluvial system only. So graded fluvial profiles meet the base level at the shoreline, because we know that at the shoreline seawater and river water, they will always remain at the same level. We have used two terms over here, one is incision, another one is aggradation. Incision is the cutting of the valley by the river system, so the channel gets deeper, so erosion is at higher rate at that time, and aggradation when sediments are accumulating in vertical direction and these are building up. In the last class, during our class on transgression regression, we have discussed about aggradation, how aggradation strata stacking pattern forms. So, in fluvial system, we can expect either aggradation or incision depending on what is the position of the equilibrium fluvial profile or graded fluvial profile for that particular river system with respect to the base level in the adjacent sea. The amount of fluvial accommodation is defined as the space between the graded profile and the actual fluvial profile. So, I will explain this with one simple diagram. Say for example, we can think of one marine basin like this. So, in this marine basin, this is the water level. So, as per definition of base level, and if we consider sea level as equivalent to the base level, then this sea level, below this we can expect this is the area for deposition, and anything above this will not be deposited, will be eroded. So, this surface can be considered as equivalent to the base level, or in many times very loosely we use the term base level equivalent to this sea level or relative sea level. Whereas, if I continue this particular surface towards the continental side, which will be like this, the same surface, but in the continental side maybe there is a river which is starting from somewhere in the uphill side towards the upstream side where it has some elevation. So, the river is starting from that elevated area, and from there it has to come down over here, because when the river is meeting the sea level, it has to come down to the same level as the sea level. So, at this position, this should be the river position, river level. So, for that purpose, the river may take different path, something may be like this, something may be like this, something may be like this, anything, which will depend on what are the nature of the rock bodies present over here, what kind of erosion is going on, what is the slope of that particular area, what is the energy of the river flow, also the tectonics, the climatic conditions which is prevalent over here. So, all these factors will control what will be the shape of this particular surface. This surface is called as the fluvial graded profile for that particular river system, and this particular surface, which is actually the extension of the base level from the marine basin, which is lying in the subsurface area, this is called as the ultimate surface of denudation, the last surface of denudation. So, always the continental side will have a tendency to reach to this surface. So, until and unless it is reaching to that surface, there will be erosions. So, within this river system, always if I draw this river profile like this, so always below this surface will have erosions, and above this will have deposition. So, this is the surface of equilibrium, that is why it is called as the equilibrium profile, equilibrium fluvial profile or fluvial graded profile. So, at this contact over here, at this contact, this water body, the river water will be in equilibrium at the same level with respect to the marine base level. So, here also there will be erosion above this surface and deposition below this surface. So, for marine base level, the definition of base level is different, whereas in case of continental system, the base level is defined, or this fluvial graded profile is defined with respect to this particular surface, which is not exactly the base level, because here the continuation of the base level is somewhere here. So, anything above this will have erosion, will be facing erosion. So, base level and fluvial graded profile, these two are considered often together, often combinedly, to define the changes in the sedimentation pattern along the marginal marine part to the continental part. So, the concept of base level is generalized to define the surface of balance between erosion and sedimentation within both marine and the continental areas. So, particularly when we look into the continental to marine transition zone, in such areas we get a combined surface, a composite surface, which is defined by the relative position of the base level in the marine part and relative position of the fluvial graded profile in the continental part. These two are merging together. For these conditions, we commonly introduce a new term, the stratigraphic base level. So, stratigraphic base level more commonly covers the wider area starting from the marine base level to the continental part. In such cases, in the river system, we can define the river system into two divisions. One area where the graded profile is directly affected by the position of the marine base level. So, that effect can be observed up to certain extent within the continent. So, in such cases, what we can expect is, for example, over here, if there is a change in this base level, rise or fall in the base level, we can expect that effect of base level change, marine base level change into the continent maybe up to this extent. So, this part up to which this effect can have a direct control over the sedimentation and erosion within the continental fluvial system. That part of the fluvial system is called as downstream controlled system. Downstream controlled system. This is that part of the river system which is close to the marine system, and the graded profile of that fluvial system is directly controlled by the position of the marine base level. Then beyond that part where we do not get this effect of base level directly in controlling the fluvial graded profile. So, what are the controls over there? Mostly tectonics and climatic condition prevailing in this area. So, based on that, we can get a different profile in this portion which is beyond this downstream part. So, that part is called as upstream controlled system or upstream controlled setting. So, within a river profile, we can get two different systems, upstream control system, downstream control system. So, downstream control system is directly related to the marine base level change, whereas upstream controlled part of the river profile is not directly affected by the marine base level change, but it is controlled by some other factors which are present in the upstream areas, like the tectonics of that particular area, climatic condition of that area, river slope of that area, the energy condition, the geology of the source rock bodies. All these factors play a major role in controlling the nature of erosion and deposition and the position of the fluvial graded profile in the upstream control setting. So, when we are talking about the composite base level, that is the stratigraphic base level, we are basically considering this part of the base level, where the continental and marine system both are clubbed together, both are considered together, as these are directly accompanying each other, complementing each other, and they are directly related to each other in terms of their changing positions. So, with this concept comes another very important concept called as accommodation. This accommodation commonly describes the amount of space that is available for the sediments to fill, is in a very simplistic words, and it is measured by the distance between base level and the depositional surface. So, what is the depositional surface? This is the final surface up to which sediments can accumulate. So, the base level controls the position of or the amount of accommodation. So, it controls how much sediments will be accumulated in that particular basin for that particular base level position. So, accommodation space or accommodation is another very important concept which help us to understand that how sediments are accumulating within a sedimentary succession. So, commonly sea level is the proxy for base level, and so the available accommodation in a marine environment is commonly measured as the distance between the sea level and the sea floor. However, it may not be correct always. I will explain that later on. So, both the sea level and the sea floor may independently change their position with respect to time, and they can change with respect to the center of the earth in response to various controls. Those controls we have already discussed in our earlier class on controlling factors of relative sea level change. So, therefore, the amount of available accommodation fluctuates depending on these variations in the sea floor, variations in the sediment layer, and the variations in the relative sea level position. which can be considered as equivalent to the base level position. So, we can take one example over here to explain this. If base level is equated with the sea level, to understand this in a more simpler way, where we are not considering the variations in waves and currents and all these things, just simply we are considering sea level equivalent to base level, then the relative sea level rise or fall, it becomes almost synonymous with the base level rise or base level fall. So, this we can now explain with respect to a simple model. Say for example, this is the sea floor, on that this much of sediments are present and this is the relative sea level. Now, if this relative sea level is rising and at the same time the substrate is falling, larger size of the arrow indicates the magnitude. That means, when I am drawing a larger arrow, this indicates the subsidence is much higher than the amount of sea level rise or fall. So, this rise arrow that I have drawn over here is smaller with respect to this one. So, what is happening here? We are getting some extra space created by this subsidence as well as the sea level is rising. So, both of them are occurring together, and in that case what we get? Overall a rise, because both of them are acting together, complementing each other, and we will get a rise in the relative sea level. And considering relative sea level as equivalent to base level, we can consider that base level is rising over here. Just the opposite of that can be considered when, say, this is the sea floor, on that we have the sediment layer, and this is the relative sea level which is now falling, and this is also rising. So, the sea floor is rising, maybe due to some tectonics, and relative sea level is falling. So, in this case the amount of space available over here will be reduced. So, accommodation will be reduced. In this case the accommodation was increasing, in this case the accommodation is decreasing. Similarly, if I consider another example, say this is the sea floor and on that this is the amount of sediments already deposited and this is the sea level. Now, this sea level is falling, relative sea level is falling, and at the same time the sea floor is going through higher amount of subsidence. So, in this case the amount of sea level fall is less than the amount of subsidence. So, effectively if I consider this one as the base level, what we are getting over here, this much of space is now available. What is that space? The amount of subsidence minus the amount of fall. So, in that case again we will get a positive accommodation, the extra amount of accommodation will be created over here. Whereas, if I get the opposite one, say for example the relative sea level is rising at higher rate and the sea floor is facing some amount of uplift, but the amount of uplift is less with respect to the amount of rise. So, what will happen now? In this case, since the sea floor is rising, so the space is effectively reducing, but at the same time relative sea level is rising at much higher rate. So, effectively the amount of space available for accumulation of sediments is again increasing. So, accommodation is positive. So, considering relative sea level as equivalent to base level, we can straightway correlate this change in the base level or change in the relative sea level with respect to the change in accommodation condition. So, sometime accommodation will be positive, sometime the accommodation will be negative. So, in that way several examples can be shown. Here in this case we are considering only the relative sea level position, and with respect to that what is the position of the sea floor or the final level of sedimentation, and with respect to that what is the amount of space available for the accumulation of sediments. However, the sedimentation in terms of sediment supply, it can vary and it can have a major role to play when we consider this amount of accommodation available with respect to the base level position. So, the sediment supply, which is commonly measured as flux, as a kind of surge of sediments coming at different fluxes, is commonly different from sedimentation, where we commonly talk in terms of the rate of sedimentation, rate of supply of the sediments. So, the amount of sediment supply can be measured as equivalent to the change in the vertical distance at any location. So, depending on the energy flux conditions within a particular basinal area, within a particular marine system, a high sediment supply does not necessarily translate into high rates of sedimentation. That means, when say you have a high energy condition prevailing in a basin, maybe there is a high rate of sedimentation, but those sediments are simply removed, simply reworked by these high energy conditions processes in that basin. So, effectively at the end of one such cycle, the amount of sediment accumulation is very low. So, the amount of sediment supply and the final accumulation of sedimentation, these two are two completely different parameters. One is how much is sediment supplied into the system, and second one, the sedimentation, is how much sediment is finally accumulating. So, it can be very low even after high rate of supply of sedimentation. So, the correct relationship in terms of the controls of stratigraphic architecture is commonly portrayed by the interplay between the rate of change in the accommodation and the rate of sedimentation. And the rate of change in accommodation is controlled by the position of the base level and the energy system, energy condition prevailing in that particular basin under that particular base level position. So, these three factors together act to control how much sediment will be finally accumulating, how much sedimentary succession will be finally forming in a particular basin. So, this is the relation between base level and accommodation. So, I can explain this with one very simple example so that it becomes little bit more clear. Again, we are thinking of say a marginal marine condition where this is the substrate, this is the relative sea level. Now, for this relative sea level position in this marginal marine part, we have some waves and tidal activities are going on, having some energy condition. So, if there is a continuous supply of sediments and that rate is balancing the energy condition of this marine basin. So, what is the meaning of this balancing? This means that in this part, when some sediments are coming in, they are supplied, immediately they were reworked by these waves and tides and they are removed from here. So, after certain time interval over this particular substrate, what we are getting? No sedimentation, because whatever sediments are coming in over here are immediately removed by the wave and tidal currents or the marine current systems which are acting over here. Their energy condition is exactly balancing the amount of sediment supplied into this basin. So, what is happening now? This particular substrate will remain unchanged. So, by definition, this surface is the base level. So, what we are getting over here in this part, the accommodation available is 0, because no sediments are allowed to get deposited over here. Those sediments are supplied, though you have this much of water space in terms of relative sea level, this much of water depth is available, but effectively you do not have the space available for accumulation of sediments. There is a very common example I can give you just to understand this. Just think of one big hall which is available for accommodation of 100 people, and there is one door to enter that hall. So, 100 people are trying to enter that room. I have put some people over there who will resist this 100 people to go into there. So, effectively for those 100 people, that space is available, the room is available, but they cannot go inside and they cannot occupy that room. So, for the actual purpose, that room is not available. So, accommodation is 0 for them. Here exactly similar kind of condition is prevailing, where sediments are supplied, but the energy condition is not allowing the sediments to accumulate over there. So, for the sediments, effectively the accommodation is 0. If I think of another condition under the same system, here the relative sea level remaining same, sediment supply is coming at the same rate, or maybe this has increased a bit, and by the time the energy condition is little bit reduced. So, due to this reduced energy condition, that means the amount of sediments which are coming in now, they are not entirely reworked. So, what will happen now? Some sediments will get deposited here like this, some sediments will get deposited. So, this much is the accommodation now, because that much of sediments can get accumulated. So, with respect to this surface, we are now getting a deposition and we are getting a positive accommodation in this case. So, even though maybe the amount of sediments supplied is 100% and the amount of sediment accumulated here may be 50%, but we have a positive accommodation now which is accumulating this 50% sediment and rest 50% is reworked from here and they are supplied in some other areas by these wave and marine current systems. So, in this case we are getting a positive accommodation. Exactly the reverse of this can happen when this energy condition is very high and the amount of sediment supply is very low, or maybe the sediment supply is going on at the same rate, but the energy condition is extremely high in the given condition. So, what will happen now? All the sediments which are coming in here will be immediately removed, and not only that, maybe this high energy can cause some amount of erosion of the earlier substrate. So, we can get a new substrate form over here and the effective accommodation is negative here in this case, because the original substrate is actually getting pushed back through erosional process. So, instead of deposition, erosion is going on now. So, effectively the accommodation is negative in this case. So, the position of the base level and what will be the amount of accommodation available in a depositional basin will be controlled not by the relative sea level position, but by the energy condition under that relative sea level position, which will actually control or allow the sediments to accumulate or will not allow the sediments to accumulate, and in some cases it may even erode the substrates. So, effectively the position of the base level controlled by this energy system with respect to the relative sea level actually controls some positive or negative accommodation or zero accommodation. So, we will continue this discussion in our next class, and there we will discuss about the other aspects of this base level and accommodation concept. So, these are some of the references that you can use for further studies. So, thank you everybody.